Okay, so please mute yourself. Please mute yourself. Okay, so this is the term we are going to know is spectrum. 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 Okay, what is spectrum? What is spectrum? One simple phenomenon I am saying. A simple phenomenon. The simple phenomenon is that a white light is passed through a prism. Through a prism. If a white light, all of you know this experiment. The white light is passed through the prism, and if a white light is passed through the prism, we see that it is bended into 7 different colors light. Yes, it's bended into 7 different colored light, and that is what is known as visual. All of you know this. That is what is known as visual. Visual. Please mute yourself, Sudeshna. Okay? That is what is known as visual. Now, why this bending of the light is taking place? Why this bending of the light is taking place? See, because the white light is passing from one medium to the other medium. What is the medium over here? Here, right? From here it is going to, suppose the prism is made up of glass. So obviously the refraction will take place, and because of the refraction this is bending. Now why this is bending into 7 lights? Actually white light is a combination of 7 electromagnetic radiation of 7 different wavelengths. Okay. Now these 7 different wavelengths, out of the 7 different wavelengths, red has got the maximum wavelength and violet has got the minimum wavelength. The violet has got the minimum wavelength. Red has got the maximum wavelength and violet has got the minimum wavelength. The one with the maximum wavelength, will bend less. So this one is red. Because it is bending less, it is supposed to go here, but it's just bending little bit, that is red. And whichever will bend maximum, that must have the less or the least wavelength. The least wavelength over here is violet, so violet is bending maximum. Fine. So we know that the visual is formed. Now the most common example of this visual formation is the rainbow. Yes, all of us have seen the rainbow. Now tell me, just one thing you tell me, that when we see the rainbow, do we see these 7 colors separately? Certainly not. All these 7 colors are just overlapping with each other, right? We cannot see them distinctly 7 colors. They are all overlapping with each other. Okay? Overlapping with each other. That type of spectrum, this is obviously a phenomenon of spectrum, that is what is known as spectrum. That type of spectrum where it is not discrete, it is an overlapping one, a continuous one, we call them as normal spectrum, okay, or we call them as continuous spectrum. Continuous spectrum. This is nothing to do with the atomic structure. This is, I just tried to tell you that what is spectrum. Now what board did, देखो first में आपका जो board के बारे में whatever idea you had, now it will slowly start changing. What board did something else. What he did, he experimented with hydrogen atom, only hydrogen atom, hydrogen molecule he took. Okay, he took it in a experimental device he made, which is called the discharge tube. Okay, in the discharge tube, as I told, we are not going to know the engineering detail in detail. There is no question of knowing the engineering thing in detail. In the discharge tube, he kept the hydrogen. Discharge tube ka speciality is what? The discharge tube ka speciality is that it has got very low pressure. The pressure is almost equal to 0. And then he passed electricity to it. Okay. This passage of electricity is responsible for the generation of the spectrum. Okay, generation of the spectrum. Fine. That is what is responsible for the generation of the spectrum of a hydrogen atom, because when the pressure is low, this hydrogen molecule is broken down into the hydrogen atom, and the hydrogen atom is responsible for those spectrum. Now I told about the continuous spectrum, I told about Vibzior, but the difference between Vibzior and the spectrum that is found in the hydrogen, in case of hydrogen gas is different. In which sense it is different? In this case, whatever spectrum we saw, they are all falling in the visible region, and that is why we can observe this, we can see this. Okay, we can very easily see this because the visible is falling in the visible region. That is why you can see these colors. But it is not necessary that all electromagnetic radiation will fall in the visible region. Visible region only very small part of the total. If the total electromagnetic radiation is this much, visible region is only this much. Okay, this much is the visible region. Baki are all non-visible region. There are so many things. For example, suppose X-ray. Just suppose X-ray. Just I am giving an example, then you can understand. X-ray. When you go for doing the X-ray, they just switch it on and the X-ray is done. The photographic plate is there under the hand or under the feet whose X-ray has to be taken. In the photographic plate, we get the image. Do we see any light? We don't see any light. Why? Because that X-ray's wavelength does not fall in the visible region. So that is not visible. That is X-ray. But how can we identify that X-ray? We can identify the X-ray by the mark it is keeping on the photographic plate. You understand the photographic plate, right? He did the same thing over here. He just took this he just took this spectrum for the hydrogen atom on the photographic plate. He got two types of spectrum. Please understand it again. I am saying it's very simple. Just whatever I am saying, please understand it. He got two types of spectrum. Okay, where he found some lines on the photographic plate. These are photographic plates. Some lines on the photographic plate. Simply some lines on the photographic plate. The lines were not studied by board. He just found it. Some lines. Same position the lines were found in the other photographic plate also. Same position. I am not drawing it like that. Same position the other photographic plate also. You can see the book. You can see that two photographic plates are given over there. And in the two photographic plates, some lines are there, but lines are placed in the same position. Lines are formed in the same position. Okay, one of them, the difference then what? What is the difference between these two? The difference between these two is in one spectrum, in one photographic plate, you will see the color of the lines. The color of the lines is black. Color of the line is black. In the other one, you will see that the color of the line is white. Color of the line is white. All of you have seen one thing. You must be knowing. Nowadays it's all digital thing, digital camera, digital thing. Phones are all digital. So photography we are taking digitally. Just few years back. That is why all of you know it. All of you have seen it. Few years back, the photographers used to now also they use for doing the films and all. They still use that. Okay. Photographers use what? Use that reels. Photographic reel. Those are called what? Those are called the photographic plates. Just like X-ray plates, the photographic plates were there. That is the only place, it's a joke, but that's the only place in the negative form, in the negative of that photographic plate, I used to look white, Otherwise, everywhere I am black. So in the negative, what is there? Negative, the white things are converted into black, and the black things are converted into white in the negatives. But when you make it in the photo form, in the positive form, the real color comes. Exactly the same over here. One of them is negative, one of them is positive. Okay, one of them is negative. One negative, positive does not have any mathematical sense. I am telling negative means that negative real. All of you must have seen that. If you go and ask your papa, mummy, anyone that just give me a negative, you will see papa's hair is white. In the negative, papa's hair is white, mummy's hair is white. Okay, why white? Because it's just converted. But in the real photograph, the hair is black. Okay, so it's like that only. Okay, that is what is called negative and positive. But it is coming in the same position. The position of the hair is not going to be displaced. It is going to be the same. Doesn't matter whether it is negative or positive. Okay, that is why these lines are also Same. But these lines are, what is the difference? Another main important difference with the normal spectrum is that these lines are all discrete line. These are not continuous line. किसी के साथ किसी का कोई relation नहीं है. They are all discrete lines, different lines. Okay? These different lines are one of this photographic plate is because of what it was named as. I am coming to that why. Okay? Named as absorption spectrum, and the other one is called emission spectrum, absorption spectrum and emission spectrum of hydrogen atom. This is his experiment. He experimented this. Then he tried to come to the conclusion कि भाई ऐसे क्यों मिला? Why did we get this? Okay. Now see, whatever concept you had, all will be changed. Simply, slowly it will be changed. First concept, it has been changed that you know that Bohr's model can be used for any atom. Absolutely wrong. It can be applied only for the hydrogen atom. Only for the hydrogen atom. Bohr's model can describe only the structure of hydrogen atom. Nobody else's. Okay. Why? He did it with the hydrogen atom. Then he told, see, it's very simple. Why these discrete lines you understood. Then he told that this electron, how many electron is present in a hydrogen atom? There is only one proton and one electron is there. Now he told that in the hydrogen atom, he just gave the theory that in the hydrogen atom there are so many energy levels. First energy level, second energy level, third energy level, fourth, fifth, sixth, seventh, eighth. Infinite energy levels are there. This is, suppose I am writing E1, E2, E3, E4, E5, E6, E7 and so on, E8, etc. till infinity. And they are non-uniformly arranged. It is not that the difference between E1 and E2 will be same as E2 and E3, will be same as E3 and E4. It's not like that. And he told the electron that is present in the hydrogen atom may be present in any of these energy levels. It may present here, it may present here, it may present here, but only at one place, at a time only at one place. Suppose the electron is placed here. Suppose the electron is placed in the 8th level. Electron is placed at the 8th level. Only one electron is there, that is placed at the 8th level. If the electron jumps from 8th to 7th, its energy will decrease. 8th level's energy is more than 7th level energy. So if it jumps from 8th to 7th, or if it jumps from 8th to 2nd, or if it jumps from 8th to 3rd, means it is jumping from higher energy to the lower energy, its energy is decreased. Energy is decreased means what? Suppose the energy over here was 100 and the energy is becoming 20. Just suppose from 100 it is becoming 20. So how much energy is decreased? 80 energy is decreased. Where this 80 energy is going? This amount of 80 energy is just emitted. This 80 energy is emitted. And the lines that is obtained in the emission spectrum, I told two types of spectrum. Emission spectrum is due to, he concluded now, is due to the jump of the electron of hydrogen atom from the higher orbital to the lower orbitals. Okay, that discrete lines are found for the jump of the electron of the hydrogen atom from the higher to the lower in case of emission spectrum. Whereas, suppose the electron is here. Now suppose the electron is here in the lower level, somewhere here. The electron is here. Now, electron is jumping from lower to the higher. Suppose it is coming from here to here. How it will come from 2nd level to the 6th level? By absorbing energy. By absorbing energy, it has to absorb the energy, then only it can go from 20 to suppose 60, whatever. Okay, 20 to 60 it will go by absorbing 40 amount of energy. And the line that is obtained because of this particular jump of electron from the lower energy level to the higher energy level is called the absorption spectrum. Is called absorption spectrum. So you understood what is emission spectra of hydrogen atom, what is absorption spectra of hydrogen atom. That is very clear. Okay. So two types of spectra we obtained, and Bohr told that the electron might present in any one of these levels, any one of these energy levels. If it is present in the higher and jumps to the lower, it will emit the energy and you will get the lines, and that is what he got. And if it is present in the lower energy level and jumps to the higher, then also we are going to get some discrete lines, and that particular energy is known as absorption energy, and the lines that is found, the discrete lines that is found, is called absorption line spectrum. Fine, board itna hi hai. Then the other scientists thought, okay fine, board had given you the photographic plate, board had given us the photographic plate, let us investigate with the photographic plate. They started investigating with the photographic plates. Different lines they used to observe. Obviously they took the emission line photographic plate. They took emission photographic plate. Okay, because the most important experiments, or the only experiments that has been done with the emission spectrum only. Okay, so they did the experiments with the emission spectrum. Emission spectrum means what? Where the electrons are falling from the higher to the lower orbitals, right? So I am just drawing the different levels of this. Suppose this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, whatever I am drawing, it can be like up to infinite. Clear? Now electrons are jumping from higher to lower, that is emission spectrum. Fine. Out of all these lines, this emission spectrum, different lines are there at different wavelengths. Actually these lines are plotted with the wavelengths. Okay, different discrete wavelengths are there. If we plot the wavelengths in this direction, the lines are like that only. Okay, depending on that. So wavelengths are differing means obviously energy is different. Wavelengths are differing means the frequency is differing. Frequency is differing means the energy is differing. All the lines has got the different energies. Okay. After they started the experiment, there are 5 different scientists. 5 different scientists got 5 different sets of lines. Sets of lines in the emission spectrum. 5 different series of lines in the emission spectrum. The first one of them was found by, or was established by, which I am writing number 2. Actually that is number 2. Okay. First one is observed by Balmer, a scientist called Balmer, B-A-L-M-E-R. Okay, Balmer. And this Balmer is responsible for finding one series. This whole spectrum consists of 5 series of lights, 5 categories of light. Okay, 5 categories of lines, spectral lines, 5 categories of energy. Out of these 5 categories, the first category was discovered, first category was established by Balmer. What he told is that, what is Balmer series? That is known as Balmer series of line. What is Balmer series? He told that when the electron jumps from the higher energy levels to the second energy level, that is why I wrote 2. Okay, from a higher energy level to the second energy level, the lines that is formed in the photographic plate are called Balmer series. This is second. If the electron jumps from 3 to 2, if the electron jumps from 4 to 2, if it is jumping from 5 to 2, 6 to 2, 7 to 2, and so on, this series of lines is known as what? This series of lines is known as Balmer series of line. And what he found, why this was investigated, this was found first out of all 5, because this particular series falls in visible region. This were visible actually, very much visible. Okay, and that is why he found this earlier than the other series, and that is what is Balmer series. Then one after another, other scientists also found the different 4 series. What are these? The first one, another one, which is called Lyman series. From the word, from the number where I had written, from here only you can understand what is Lyman series. Lyman series means the lines that is responsible, or that is generated due to the fall of the electron from the higher orbitals to which orbital? To the first orbital, or to the first energy level. Means what is Lyman series? The electron is jumping to the first from the higher, from 2, from 3, from 4, from 5. All these lines is coming in one series, and that particular series is called Lyman series. That is what is known as Lyman series. Okay. The next one, the third one, obviously this is found in UV region. UV region. UV region means ultraviolet region. This is not in visible region. That particular series of lines is found in the ultraviolet region. The wavelength falls in the ultraviolet region. Next one is called bracket. He is the scientist who found it, bracket series. So obviously whenever I wrote 3, all of you can understand that the electron is falling from the higher to the third one. Whatever lines are found for this is called what? Is called bracket series. Okay. The next one is called Paschen. Next one, the fourth one is called Paschen series. That Paschen series also can understand, since I wrote fourth means what? The electrons are falling from the higher orbital to the fourth orbital, and the lines that is obtained, or the series of lines that is obtained, is called the Paschen series. Okay, and the last one is called P-Fund series. P-Fund series, which is actually falling to which level? Falling to fifth level from the higher levels. So this series of line is known as what? This series of line is known as P-Fund series. Okay, all these three series after the Balmer series, all these three series are falling in the infrared region. That is why their discovery was late. Okay, first discovery was of Balmer series, then this. Now suppose I'm talking of, forget about. Now if I ask you any line, you can very easily tell me that which series of light is it. Suppose if I ask you, this 5 series of light is found in case of what? In case of hydrogen spectrum. On board only studied about hydrogen spectrum. Suppose now I am asking you this line. Suppose this line I am asking. This line, kahin se bhi pade. That is not our interest. Where it is falling is our interest. If I ask you this particular line will fall in which series? So you see it is falling in the second level. Where the second level is falling in and coming in which series? Second level is coming in Balmer series. If I ask you about this particular line, so what series it is? From wherever it is falling. It is falling to where? It is falling to level 1, first level. So first level, whichever electron is falling and generating the line is called what? Is called Lyman series. So this is one of the lines of the Lyman series. Now suppose if I ask you what is the energy that is emitted? Obviously from here electron is falling here, and during that some amount of energy is emitted. If I ask you what is the amount of energy that is emitted for the fall from this is which level? Seventh level to one level, first level. What is the amount of energy that is released? What is the amount of energy that is emitted? Okay. Hence comes another scientist. He calculated it. He calculated the energy of each level of the hydrogen atom. Again I am saying hydrogen atom. He calculated the energy of the hydrogen atom of each level, and he came to the formula of this. Okay, he just gave 2 equations. You see, it's very simple, and from there you can find out the energy very easily. And that scientist's name is Rydberg. He told that any spectral line, emission spectral line of the hydrogen atom has got wave number. If we know the wave number, we know wavelength. If we know the wavelength, we know frequency. If we know the frequency, we know energy. Energy is h nu. Okay, so if you know nu, you can find out the energy. Nu, how can you get it? From lambda. Lambda is equal to c by nu. So if you know nu, you know lambda. And from where you will get lambda? From nu bar you will get lambda. Nu bar equal to what? 1 by lambda. So you can get it. Okay, it's very simple. So what he found, this is, you have to know it only, and it is nothing, no deduction, nothing. He experimentally found it. He found nu bar equal to 109677 into 1 by n1 square minus 1 by n2 square. Okay, 109677 1 by n1 square minus 1 by n2 square centimeter inverse. That time CGS system was much in use, so he talked about in CGS system only. Okay, this is nu bar for which light? What is n1? What is n2? Let me just table it. You can understand that. You can understand that. Now the same series, these 5 series I will write in a tabular form so that you can understand it. Tabular form. Now here I am going to write down the series. Balmer. Sorry, first one is what? Lyman, then Balmer, then bracket, then Pasture, and then P-fund. Okay, here I am going to write down N1 and N2. N1 is the level. N1 is the level where the electron is falling. So for Lyman, N1 is 1. For Balmer, N1 is 2. It's falling in the second level. For bracket, it's falling in the third level. For Pasture, it is falling in the fourth level. For P-fund, it is falling in the fifth level. We know this. That is the series. And what is the value of N2? From where it is falling. From which level it is falling. So for Lyman series, it is falling from the higher levels than the one. So for Lyman series, N2 can be 2, 3, anything till infinity. For Balmer series, it can be 3, 4, anything. It will fall in second level. For this series, it will be 4, 5, etc. For this, it is 5, 6, etc. For this is 6, 7, etc. This is the tabular form of the different series or 5 different series of the emission spectrum. Okay. Now the question, suppose if I ask you, so what is N1? You understood what is N1? N1 is what? N1 is nothing but the level where the electron is falling. And N2 is what? N2 is the level of the from where the electron is falling. If you know these two levels, you can very easily find out nu bar. And if you know the nu bar, you can find out the energy. He gave the expression for energy also. Okay? He gave the energy of expression also for each level. He told En. En means energy of nth level. Energy of nth level. Okay? Energy of nth level equal to minus 2.18 into 10 to the power minus 18 1 by n square. Minus 2.18. Again and again I am saying these are only for the hydrogen atoms. 2.18 into 10 to the power minus 18 into 1 by n square. Okay? That is what is energy. So if I ask you what is the energy of the 10th level, you can very easily say E10 equal to minus 2.18 into 10 to the power minus 18 1 by 10 square. Obviously the energy's unit is joule. Okay? From here only he calculated. Both this term as well as this term, both this term are called Rydberg constant. These are called Rydberg constant. Okay? Now, दो Rydberg constant है क्या? नहीं. This one 109677 centimeter inverse is called Rydberg constant in terms of wave number. And this one minus 2.18 into 10 to the power 18 is called Rydberg constant in terms of energy. Now, one thing you should be knowing, 2 minutes, little bit more than 2 minutes is there, so I can finish it up. Okay, so you can see this, then I will upload the video, you can watch it again, and the concept should be very, very clear. Okay, and whatever doubts is there, you are going to ask me next day. Please mute yourself. Okay, you will ask me next day, no issues. Whatever doubts are there, I am going to sit with you next day. Now the thing is that minus 2.18, the energy of the electron is minus. Why the energy of the electron is minus? N is always positive. N is what? First, second, third, fourth, fifth. Okay, so that is always positive. If N is always positive, why the energy is negative? Just try to understand this. Once again I am saying, he talked only about the hydrogen atom. This is the nucleus. Now whatever you know, I am trying to draw in that manner. This is the nucleus where the proton is there. Now both told that there are so many energy levels where the electron may stay, electron may be present. Suppose that this is infinite energy level at very far away from the nucleus. If the electron is present here, if the electron of the hydrogen atom is present here, it is hardly experiencing any force of attraction with the nucleus because it is far away from the nucleus. At that condition, the energy of this electron is considered as 0. The energy of this is 0. Okay. Now when it is falling down, when this is falling down to the or coming towards the nucleus, it is falling down to the lesser energy levels. If it falls down to the lesser energy level, it will lose the energy. If it loses the energy, it will become less than 0. It was 0 at infinity, now it is coming to the lower level, means what? It will become less than 0, and less than 0 means what? Less than 0 means negative. That is why the energy of the electron is negative in case of hydrogen atom. Okay, so the time is up today. I am going to upload this video today itself.